Hello, boys and girls. I'm going to take you into some revision for your June examination. So let's look at integers. So I hope you're preparing well for your June examination. Okay, in terms of integers, we're going to, first question says arrange in ascending order. So now what does ascending order mean? It means from the lowest to the highest. Like when you ascend stairs, it's from the lowest, ascending order is lowest to the highest. So your lowest value here, remember, is your negative 50. Remember, with normal numbers, without the negative sign, your normal values, 0 is lower than 25. So we have 0 and then 25. So increasing from the lowest to the highest. Now, in terms of negative numbers, your number line reflects that your negative 50 is way lower than your negative 8 or negative 3. So if we're going to quickly draw a number line for you here, if we have 0 here in the center, then the numbers on the right of 0, you know, are your positive numbers. They're going to increase. But your numbers on this side, right? So if this is a, let's put 0 here, you have 0 here, then this may be, for example, 25. 25 is on your right. So it's going to increase. It's going from lowest to highest. Now, in this case, you can have, for example, -3 on this side. And then your -8 or negative 8 is going to be further down. And then you're going to have a negative 50 further down. Right, so your negative 50 is on this side. Then you're going to have -8, -3. So you start with your lowest number. Okay. You start with your lower number. And the lower number is -50, and you're moving on to positive 25. Now, when you're comparing integers, always draw your number line in your mind. And you find that -8 will be lower down than -6. So if you draw a number line, your -8 again is lower down than your -6. So you'll have -8 here. So if you're going to have -8 here, right, you can have -8 here, and then you're going to have a -6 on the side. So your -8 is lower down than your -6. So -6 is greater. So if you're looking at this, -6 is larger than -8. There's your greater than sign. Because we have to compare -6 with -8, and -6 is larger. The next aspect is, how do you add and subtract integers, and then multiply and divide? Now, when you're adding and subtracting, you can put the entire expression in your calculator. It will give you the answer. But always learn to, especially at home, learn to do it mentally and check with your calculator. If no working is required, you can put the entire thing in the calculator if you have the scientific calculator that has the brackets. But let's just revise how we do it mentally. So according to BODMAS rule, it's multiplication first. So on multiplying, okay, we got our -2 here. You're multiplying 3 times 6 is 18. And the rules for multiplication of integers, positive times a negative is a negative. And here, negative times a negative is a positive. And we have 5, because this is a 1. Although you can't see the number, it's known to be a 1 outside the bracket. 1 times 5 is 5. This you can put in your calculator again, or -2, -18, you're adding. That's -20. There's 20 negative numbers in total, and there's 5 positive. So there are more negative numbers, so we're going to get a negative answer. So -20 or -20 plus 5 is -15. Multiplication, 8 times 2 is 16. Negative times a positive is negative. 3 times 4 is 12. And a positive outside, yeah, times this negative is going to give you negative. And when multiplying, these two numbers. 16 times 12 is 192. And negative times negative is positive. As I said again, we can put the numbers in the calculator to check your answer. Working with fractions, we need to convert from an improper fraction to a mixed fraction. Now, if you have a scientific calculator, it can be done on a calculator. So I'm going to do this mentally first. 17 divided by 5. Now, this is a mixed, this is an improper fraction. It's not a proper fraction. A proper fraction will have a smaller numerator and a larger the bottom denominator, like a half or 2/3, or just looking at 2 over 5. That's a proper fraction, the 2 over 5. 2 is smaller than 5. Now, this is an improper fraction because the numerator is large. So to convert it to a mixed fraction, the question says convert your improper fraction to a mixed fraction. So 5 goes into 17. How many times? 3 times. So if you divide 17 by 5, it goes there 3 times. So 5 goes into 17 3 times. Remainder, 5 3 is a 15. Remainder 2 to give you the 17. So 2 over 5. Same here. 4 goes into 28 7 times. There is no remainder, so there is no fraction here. It's a whole number of 7. Now, when you're converting from a mixed fraction to an improper fraction, now remember, mixed fraction means a whole number and a fraction. So there's a whole number and a fraction. To get that as an improper fraction, we work in reverse. It's 2 times 3, which is 6 plus 2, that's 8. 8 over 3. So you're multiplying the whole number here times the base. 2 times 3 is 6. 6 plus 2 is 8 over 3. Here, 5 times 5 is 25. 25 plus 3 is 28 over 5. 5 5s are 25. 25 plus 3 is 28 over 5. Now, to do these conversions, we have a calculator like this. Then we can use these buttons here for the calculator. Now, first, if you're entering a value, like for example, you need to enter half, then you need to use this. If you can look at this, these are space holders. Space holders means you're going to enter fractions. So the white one is reflected something like this. It means you can enter a simple fraction, right? Not a mixed fraction. So if you're entering half, you click on this button, you'll get something like this. You type in your 1, you type in your 2. Now these arrows allow you to move up and down on these fractions. And if you got a mixed number, that allows you to move to the left to type in a number, or to the right to your fraction. So you use this whenever you need to enter fractions. So if I need to enter half, I press this button here. If I need to enter 2 and 2/3, for example, a mixed fraction, I need to press Shift, this yellow, and then I get the yellow at the bottom. It gives me a space to enter your whole number as well as a space to enter your fraction. These fractions here, if I want to convert them to decimal, then I need this number here, this button here. It converts it to a decimal number. Like a half will give me 0.5, or 1.5 will give me 1.5. Now, if I have a number or something calculated already, like I have a 1.5 on my calculator already, and then I need to view it as a fraction, then at the bottom, can you see the yellow? Shift and the yellow will allow me to view it as a fraction. So it'll give me as 1.5. So when you have a number already on your calculator and you just need to view it as a fraction, then you work with this button. This button allows you either in the top to view it as a decimal, or Shift and you press this button, you'll view it as a fraction. So this allows you to move between fraction and decimal. So when you want to put in an improper fraction, if you can enter it through here, but you can view it as a mixed fraction by using Shift and your decimal. So that's working with your fractions. now we need to use your calculator to add. To add this, you use your calculator and you punch in this number here. And you put a plus sign and you punch in. Now to do this addition of fractions, then we're going to use again just this one because we're entering the value. So you click on this or shift, and here you'll have your mixed number. You click on it, you enter your fraction, the plus sign, and then you enter your other fraction and the equal to sign. And if you want your answer to be shown as a decimal, it will appear automatically as a decimal. But if you want it again as a fraction, then you shift, and this will give it to you as a fraction. I have a video on fractions. We'll share that later on. So you add that, you will get this value. And if you're multiplying, you will get 238 over 9. But if you use your calculator, you can convert that to a mixed number. For this video, we will not go into conversion and addition using LCD, lowest common denominator, because we are testing the use of the calculator. We'll do that on another video. Now next, your exponents, simplification of your exponents, 5 to the exponent 3 and 5 to the exponent 4. When you're multiplying, your laws, we did addition, sorry, we did the laws of exponents. When you're multiplying, we add the index. We're dividing, we subtract the index. And if you're raising a power to a power, we multiply. That's the 3 laws we learned. And the 4th law was the law of 0. Anything raised to 0 is 1. So when you multiply, we add the exponents. When we divide, we're subtracting. When we're raising a power to a power, we're multiplying. So here, multiplying 5, 3, 5, 4, 3 plus 4 will give me 7. 3 plus 4 gives me 7. Next one, we are multiplying all of this, which means we add the exponents. That's 3 plus 4 plus 5 plus 1. There's a 1 here, which is 13. Here we are dividing, so we subtract 6 minus 10. 6 minus 10 will give you a negative 4. So into the 6 minus 10. 6 minus 10 is negative 4. Or you can look at it this way. The n to the 6 and n to the 10 here, there's more n's being multiplied at the bottom. So how many more? There's 4. There's 4 extra here compared to there's 6 here and there's 10 here. So we have 4 extra at the bottom. So if you want to write it as a positive exponent, then you need to have n to the 4 at the bottom. But if you're doing the laws, you're subtracting 6 minus 10 will give you n to the 4. And so in this case here, you'd have had 6 minus 10 and 6 minus 10 here is n to the negative 4, which is right. So we have the option of this works out as 6 minus 10 because you're subtracting. We're subtracting because we're dividing. When you divide, you subtract 6 minus 10, which is n to the negative 4. So that is how you could do it, or you can use this method here. Remember, a negative exponent, to keep it positive, this at the top, we write it at the bottom. And we'll do more about that on another day. Now we are raising a power to an exponent. So we're squaring 5x to the 4. So 5 squared is 25. X to the 4 squared you multiply. 4 times 2 is 8. So remember, when it's raised to an exponent, you multiply. 4 times 2 is 8. So notice the difference. Here we're adding 3 plus 4 gives you 7, but here we are multiplying. Now we are dividing. If we're dividing, the law for exponent is subtract. Okay, 12 divided by 2 is 6. Now your integer values, your normal integer values will work with normal division. 12 divided by 2, which is 6. Here we subtract 5 minus 4. 5 minus 4 is 1. 5 minus 4 is 1. This is 2 to the 0. 2 to the 0. So 2 to the 0, anything raised to 0 is 1. So 2 to the 0 is 1. X to the 0 is also 1. And 1 times the 3 gives me 3. So 2 to the 0 is 1. Here, x, not 3, but x to the 0. X to the 0 is 1. And the 1 times the 3 is going to give me 3. Remember, so we're not raising 3 to the 0, we're only raising the x. So this entire x to the 0 becomes 1. So your entire x to the 0 becomes 1. And 3 times the 1 will give me 3. So your entire x to 0 is a 1. The next one is on numeric and geometric patterns. If you look at this pattern here, 1, 5, 9, 13. We need to describe the above pattern. So we look at 1 to 5. How do you get from 1 to 5? The possibility is add 4. Let's see if that will work for the next one. From 5 to 9. If you add 4 to 5, you get 9. If you add 4 to 9, you get 13. So by adding 4, add 4 to each term will give you the next term. So that is the description for the pattern. To write a general rule to find the nth term. Nth term means any term. What is the rule can be used to find any term down the line? We only have 1, 2, 3, 4 terms. So looking at what is the rule, that's your first term. This is your second term. This is your third term. And this is your fourth term. So we're looking at the possible rule to work out any term. So what rule can we use to work out any term? The rule is 4n minus 3. Now, how do we get an answer like this? Now, the common difference is always the common difference times the position. So what's our common difference? Our common difference was 4. Remember, we had to add 4 to each term. So to get your first term, your common difference of 4 times the first term. 4 times 1 is 4. Now, how do we get 1? By subtracting 3, we get 1. So 4 times the first term is 4 minus 3 gets 1. So let's try for the second term. It's a common difference, which is 4 times the position. 4 times 2 is 8. Now from 8, how do we get to 5? 8 minus 3 gives you 5. Now you can see that we have to subtract 3 every time. So your general rule will be 4 times n, which is your position, minus 3. So your general rule will always have an n there because n is your position. And then we're looking at your constant difference. So constant difference from your position, and then decide whether you must add or subtract a number to take you to each term. So here we realize we have to subtract, because we look at the second term, 4 times 2 is 8, and to get 5, 8 minus 3 gives me 5. And your third term will be 4 times 3, which is 12. 12 minus 5. Sorry, yeah, 4 times 3 is 12. 12 minus 3, sorry, it's 12 minus 3. So your third term will be 4 times 3 minus 3. 4 times 3 is 12. And 12 minus 3 will be 9. To calculate the value of the 50th term, use your your formula. Right, your formula was 4n minus 3. That's your general formula. So your 50th term means not nth term, not 50th. So in place of n, we're looking at the number 50. So 4 times 50 minus 3. So in place of n, we work with 50. So it's 4 times 50 minus 3. 4 times 50 minus 3. Remember, your brackets means times. You can put the times sign if you want. So 4 times 50, which is 200. 200 minus 3 is 197. So that's your answer. Next one, which term in the above sequence will have an output value of 537? We are saying which term down the line will give me an answer of 537. So we know that 4n minus 3 must be equal to, the term must be equal to 537. Right? So 4n minus 3 is equal to 537. So you can ask yourself, 4 times what number minus 3 will give me 537? Right? So 4 times what number minus 3 can give you 537. And you, through trial and error, you will probably get 135. 4 times 135 minus 3 is going to give me 537. But we can solve this answer. 4 times what minus 3 is equal to 537. So what we do is we try to solve, or we solve for n. So we need to get rid of minus 3. So 4n minus 3 plus 3 will give me 0 for this. We'll be to get rid of minus 3, go to add 3, because minus 3 plus 3 gives me 0. If you're adding on this side of an equation, you have to add on that side, because an equation is always balanced. So you're going to add a plus 3 here. So this gives me 0, so it's out of the equation. And 537 plus 3 is 540. Now I need to work out n value. To work out n value, I need to get rid of 4. And the only way to do that is to divide by 4. Because 4 divided by 4 gives me 1n. There's it, 1n. It's just an n. So I need to divide on that side, because to get rid of 4 from this side, we have to divide by 4. So we have to do it the same on the other side of the equation. We divide by 4. And it gives you 135. So using the laws for equation, we can solve for n. That's 135. Or you can think about your answer and what number times 4 minus 3 will give you 197. You can also work backwards in the revision answers that you're given in class, where when you subtract 3, so you work backwards, and now you add 3, which is what we did. We multiplying by 4, we work backwards, we divide by 4. So working backwards is you add a 3 and you divide by 4. Here you're subtracting 3 and you're multiplying by 4. So working backwards is now you add a 3, 537 times 3 is 540. Here you are multiplying by 4, then here you divide by 4. Now I introduced to you equations, because that's the section we covering next term. Next section is on functions and relations. Now in functions and relations, it's substitution. You have these are your input values, and that's your output values. So if you input 1 into this flow diagram, if you input 1, what will the answer be? It means you got to substitute. You have to substitute 1 in place of x. So if you're substituting 1 in place of x, then you will have -3. Substitute using your bracket. -3 times 1 plus 1. That's what you're going to work on. So you can put this in your calculator, or you can do it mentally. -3 times 1. A positive times a negative is negative. So that's -3 plus 1. And that answer will give you -2. There are more negative signs, so you're going to get a negative answer. Negative is the largest sign, so you're going to get a negative answer. 3 and 1, positive 1. So -3 plus 1 is 2. Or 3 minus 1 is 2. And the sign is negative. It's more negative number, so the answer is -2. That, or you can put this in your calculator to check your answer. Now, when you're working for the next one to get your answer, use your input value is 3. It means in this place, we're going to have a 3 and not a 1 anymore. So working with 3 times 3 is 9. So this gives me 9. And negative 9 plus 1 will give me negative 8. Or you can use your calculator. Negative 9 plus 1 is negative 8. But you can see from here, the difference is 9 minus 1 is 8, but they are more negative. Negative is a larger number, so you have a negative sign. Now, this is working backwards. So you're going to ask yourself 3 times what? Right, so it means you don't have an answer here. 3 times what minus plus 1 is going to give me an answer of negative 10. So 3 times what plus 1 will give you an answer of negative 10. Sorry. Okay, sorry. To give an answer of negative 29. Right, there's your answer, negative 29. Your input, we don't know. I put the answer in now, but the input we didn't know, but we know the answer is negative 9. So how do we get to know that this answer is 10? So 3 times what plus 1 will give you 29. And the answer is 10. So 3 times 10 is 30. That's negative 30 plus 1 is negative 29. Now, this is also an equation. So if you look at this, negative 3x plus 1 is equal to negative 29. So that's an equation. We're saying that this algebraic rule here, negative 3x plus 1 must give you an answer of negative 29. So using this now, how do we solve for x? So if we use the rules we learned previously for equations, we have a positive 1. To remove positive 1, we need to put a negative 1. So because a positive 1 and a negative 1 will give me a 0, so we can get rid of the 1. But in an equation, it must be balanced. So if I add a negative 1 here, if I put in a negative 1, I have to put the negative 1 here as well. So notice a negative 1 and a negative 1. So this will give me a 0, which means I won't have any 1s here. But negative 29, negative 1 is negative 30. They're all negative numbers. We're not multiplying here, so be guarded. If you're unsure, you can punch it into the calculator. Negative 29, negative 1, you're going to get negative 30. The negative 30 numbers here. Now, to get rid of negative 3, we divide by negative 3x. That means you've got to divide that by negative 3. And if you divide negative 3 by negative 3, you're going to get a 1, just x. And negative 30 divided by negative 3 gives you 10. But remember, we said you can also work backwards. For example, if you have 29 here, negative 29, you're adding 1 here, then you're subtracting 1. There's it here. We subtracted 1, so you get minus 30. Now you're multiplying by 3, so we divide by 3. Right, so it means you're going to divide both these by negative 3. To get rid of the negative 3, we have to divide. And we have to divide. And you divide negative 30 by negative 3. You can use your calculator or mentally. 3 goes into 3 one time. And negative divided by negative is positive. 2 negatives means positive when you're multiplying or dividing. The next section is the same, similar idea. You can use your calculator and substitute, but we have x values here. This is your algebraic rule. We don't have it in the form of flow diagram. We have it in a table. So we have all your x values here. We need to work out your y values. So if x is minus 2, you take your equation, y is equal to 4x minus 4. You put minus 2 there, and you can work it out. 4 times minus 2 minus 4. And the answer is minus 12 or negative 12. 4 times 2 is 8, negative 4 is negative 12. So we can substitute in your calculator. It saves you time. But remember, whenever you're given this application for classwork, please do it mentally. Algebraic expressions. Now we're going to convert your algebraic language. You're going to convert from words to a mathematical expression or algebraic expression. So if we say a number is increased by 4, we don't know what the number is, so we let the number be x. X is increased by 4, so it have x plus 4. Increase means plus. Decrease will mean minus. The quotient of 9 and 3. Quotient means you're going to divide the answer after you divide. So it's 9 divided by 3, which is 3. The quotient, the answer of 9 and 3. So 9 divided by 3. The sum. So we know we're going to have a plus sign somewhere. The sum of the square root of a number. We don't know what the number is, but we know there's a square root sign. So we're looking at the square root sign. We're looking at the sum, a number, and 5. So square root of the number, and the square root of the number is square root of x. The sum is plus, and the number is 5. The numerical number here is 5. So square root of a number, which is x, which we don't know, plus the 5. Ben is X years old. His brother is half his age. So how old is his brother? If the brother is half the age, it should be X divided by 2. Give you half. Now we still remember, always remember this key that Ben is X years old. Now they'll know how old will Ben be the next year. So if you're looking at the next year, Ben is X years old. The next year is 1 year later. And 1 year later will be X plus 1. Now we're looking at how old was Ben 5 years ago. 5 years ago means X minus 5. Because that was in the past. You're going to subtract. This is in the future. That's plus 1. Right, given an expression, this is 3x times 6y minus 5x plus 4. How many terms are there in the expression? Terms are separated by plus or a minus. So there's a minus sign, there's a plus sign. So if you're separating the terms, then we have a 4, 5x, and this entire thing is one term because you're separating. So there are 3 terms in the expression. What is the constant term? The constant term in the expression is 4. A constant term is a term that does not have a numerical value. So your constant term is 4. Write down the coefficient of x. In this particular example, we have x that appears twice. So if we only had this, then the coefficient will be -5. The coefficient is a number in front of x. But remember, it's also, when you look at the number, you also look at the sign that accompanies that number. And there's another x. Sorry. So 3x, the number in front of x is 3. So your coefficient of 3x is 3. We also have a -5x. So the coefficient of -5x is -5. Don't forget about the sign. If we have a letter without a number in front, then the coefficient is 1. So if we have, for example, the coefficient of, say, plus or times y, we didn't have a 6, then that coefficient will be 1. So if there's no number in front of a letter, the coefficient is 1. In this case, there is a number, so the coefficient was 3. There is a number here, which is -5. Simplification of algebraic expressions. We're going to use the rules for exponents here when it comes to multiplication or division. But for addition, we don't change the exponents. We have a plus a plus a, there are 3 a's. right? So that's 3a. We do not change the exponents. You don't have a cubed because there's 3 a's. It's 3 a's. Only when you see multiplication, then you consider changing the exponent value, because then we're using the rules for exponents. But when you're adding or subtracting, we do not interfere with the exponent value. Remember that. When you're adding or subtracting, do not change the exponent value. Like this is saying apple plus apple plus apple, you've got 3 apples. Now here, we're multiplying 2 times 3 is 6. X, we are multiplying. So x times x will be, there's a 1 here. 1 plus 5 is 6. Because we are multiplying, we add the exponents. The rule for exponents is when you're multiplying, you add. When you're dividing, you subtract. It doesn't say anything about this, so be careful. Only when you're multiplying, you add your exponents. Now here, are we multiplying? No. So should we change the exponents? No. So what we're looking for here is like terms, because we need to decide what can we add, right? We can't add everything, so we need to decide. We can only add like terms. So what is like? Like means it must look identical in terms of the letter or the variable and the exponent. We have a p here and we have a p here. They look identical. Then we have this one and this one. These are y's. So this p and p are identical, and the y and the y are identical. So p plus 3 minus 8. Right, 8 minus 3 is 5. So it's 5, but they're more negative. So it's the difference between 3 and 8, which is 5, and they're more negative. So negative 5p. Now this is a 7 plus 7, or positive 7 and a negative 2. The difference between 7 and 2 is 5, but they are more positive. Positive 7. So the answer is positive 5. Now those are still having some issues with integers. You can use your calculator to work out some of it. For example, if I need to work out 3 plus 3 minus 8, so I can put in there 3 minus 8 on the calculator, and it will give me a negative 5 or minus 5. So I know the answer for P, yes, P here, right? Then we know the answer for P plus 3p and negative 8p will be 3 minus 8. There's 3 minus 8, give me negative 5, and it belongs to P. Similarly, I can say type in 7 minus 2, and I'll get the answer 5. But you know 7 minus 2 is 5. And you know that 7 minus 2 is 5. Now here is similarly addition and subtraction. It is not multiplication, so we don't change the exponents, right? It's addition and subtraction. Now, what are like terms? We've got x and y squared. Do we have another x only and y squared? Yes, this is x, y squared, and that is also x, y squared. So we have all 3 that are like, which means I can add all 3. So I can work out 2 plus 5 minus 3. So here again, you can do this on the calculator or mentally. 2 plus 5 minus 3. And that you'll see there's 2 plus 5 is 7. 7 minus 3 is, sorry, it's not minus 3. It's 2 plus 5 minus 9. That's minus 9. So 2 plus 5 is 7. So we're actually looking at 7 minus 9. And they are more negative there. So the answer will be negative 2. Right. Difference between 7 and 9 is 2, and there's more negative, so the answer is negative 2. But as I said, you can type this in and get your answer as well. And your x and y squared remains the same because we are not multiplying. Only when you multiply, then we add the exponents. This is not multiplication. This is addition and subtraction of like terms. Here 2 is addition and subtraction of like terms. We have m squared, we have m squared. Both are like, they're the same. This is a 1, negative 1 plus 2. and -1 plus 2. So -1 plus 2. And so 2 minus 1 is a positive number because there are more positive values. There are more 2, plus 2 and 1 minus 1. So 2 minus 1, we have 1. Right, so they're more positive than negative. So the answer cannot be -1 as your answer. You can see that we have more. We have more positive truth. The next aspect you need to remember and learn. There are other videos on Bedlam Secondary YouTube channel that covers percentages, percentage increase, decrease in other revision application, as well as ratio. I'm going to go through ratio because ratio was done in term 1. Now, an example on ratio is sharing 30 sweets between Albert and Anila in the ratio 2:3. So sharing 30 sweets between Albert and Anila in the ratio, let me erase this, sorry, all this working, right? So there's 2 boys here and we're sharing the sweets in the ratio 2:3. Now, when we're sharing, you need to work out the total parts. 2 plus 3 is 5. So out of the 5 parts, 2 out of the 5 is for Albert, 2 parts out of the 5 parts is Albert, and 3 out of the 5 is for Anila. So 2 out of 5 times the total sweets, which is 30, will give you 12. Because 5 goes into 30, 6 times 2 is 12. Now, if Albert is getting 12 sweets, then 30 minus 12 will give you 18 for Anila. Or you can work out that Anila is 3 out of 5. 3 out of the total parts. So 3 out of 5 times 30 gives you 18. That's a quick revision on ratio. But there are other videos. They're on the percentage, working with percentages and percentage increase and decrease. So watch those videos and go over that work for your revision as well. I'm going to show you a quick video on how to use the calculator. And we'll end here after the video. Thank you, boys and girls. Hope you have a good revision session.
Hello, and welcome to the Calculator Guide, Mixed Numbers to Fractions, or Fractions to Mixed Numbers. We're going to learn how to change between fractions and mixed numbers in this video. First, let's just have a reminder of the fraction button. Press the fraction button and input a quarter using the Greek plane. Press equals, and we have a quarter displayed here. Remember, we can use the SD button to change between a fraction and a decimal. Let's try now to change between a fraction and a mixed number. To do this, we're going to input an improper fraction, 5/3. And then press equals. We're going to change the improper fraction to a mixed number using this function here. To access this, we need to press the shift button and then the SD button. And here we have our mixed number, 1 2/3. If we press shift and then the same button again, SD, we can change that back then to the improper fraction, 5/3. Let's have a look now at inputting a mixed number. You can see that that's here above the fraction button. So again, we need to press shift first. Shift, so we have the little S here in the top left hand corner. And then press the fraction button to the mixed number. We're going to input 2 3/5. So first input your 2 as your integer component, and then 3/5 as the fraction component. Press equals. The calculator is automatically giving the answer as an improper fraction, 13 over 5. To display this as a mixed number, we need to use that function again. So shift and SD. And here we have 2 3/5. Remember, we can press the SD button as well to display it as a decimal. 2.6. That's it for this video. Thank you very much for watching, and we'll see you again next time on the K.